Now let's talk about SPY versus VOO. Reed, were you the VOO master?
I do like VOO.
Okay, well let's talk about it. So what I've got here are the two index funds. I've got their expense ratios, and you can tell that SPY is more than 3 times as expensive as VOO. That sucks. Okay, now let's say, well, wait a minute, maybe people are interested in SPY because it's just a bigger fund, it's more popular. Wrong. There's only 622 billion in SPY versus 1.51 trillion in VOO. So there's got to be some other reason that people, other than ignorance like I was, are using SPY. And the answer comes down to the average volume. Average daily volume for SPY is 16 times as great. Now, what does that mean? It means if you're doing high-speed trading, that you can buy and sell SPY a whole lot, it's a whole lot more liquid. By the way, liquid means the ability to buy something at or near the full market value in a short amount of time. And so you can buy VOO at full market value, but there might not be as many people out there interested in buying or selling at the exact moment that you want to be, so there might be a delay of microseconds. Do you guys know about fast, high frequency of trading? If the microseconds cost you billions, right? And so that's probably why we're seeing people still using SPY in spite of its obvious downfalls. Now, for me, an old guy that just pushes money in and forgets it, VOO is definitely the way to go. So I had some cash and I'm like, damn, I'm gonna get some VOO, right? And so that's what I did after our talk, after I researched all this, and so this is worth a coin to you. Are you ready? Woo! Oh, damn it. Okay, now I do have to ask you, did you get a haircut?
Yeah.
Are you looking for advice on a new stylist?
Yeah.
Okay. Folks, that was a softball insult in case you didn't catch it, right? Okay.
No, he didn't get me right this time. He normally gets me right. I think there's something on his mind today. It's a little flat.
Yeah, so I had this lady, and if she was happy, if I walked in there and she was happy, I knew I was gonna get a crappy haircut. And so someone finally told me, they said, well, try to piss her off a little bit before she cuts your hair, which was counterintuitive to me, but it worked. Now, I'm not saying I got great hair. I only pay $20 for my haircut, so that says a lot, right? Okay, on with the story. Last time we talked about these two things, and we said that there's the central tendency, or the middle finger, right? And that it had to be higher for small company stocks than for large company stocks. Why? Yeah, risk and return have to go together. And how can we, looking at these two pictures, how can we know that small company stocks are riskier? Yeah, because they're more spread out, right? So you've got your large company stocks like this, and then you've got your small company stocks all spread out. So we know now risk and reward have to go together, and the riskier a security is, the greater the return must be. But there is this thing, it's a hypothetical construct called the risk-free asset. The risk-free asset, the idea is that there's at least one asset that is totally risk-free that we can invest in and receive a positive return. Now, it doesn't necessarily always have to be greater than inflation, but it is positive. Okay, now, what asset did we talk about last time that was the closest thing to a risk-free asset that we could find? Yeah, treasury bills. And so because we cannot observe this risk-free asset, theoretical risk-free asset directly, we are going to use the yield on the 3-month treasury as our stand-in for this mysterious risk-free rate. Now, the second thought is, if something is returning more than the risk-free rate, that additional return must be a compensation for bearing risk. Anything over and above that risk-free rate must be a compensation for bearing risk. And so we call this thing a risk premium, and it's just the expected return on this thing minus the risk-free rate. And so the risk premium on anything is just the return on that thing minus the risk-free rate. Okay, so the higher the risk premium, the more risky we know this is. Have any of you guys ever watched the TV show American Greed? Oh my goodness, go out and Google it. It's amazing. So it's all about con men and all sorts of other evil people. But one of the common schemes is that these con people, because women are involved too, they will talk to old people and they will say, oh, by the way, do you think old people are risk averse, or are they willing to take lots of risk? They're very risk averse, right? Because they've got to live off this money. And so the con people say, wait a minute, I can get you a risk-free investment that pays 10% per year. Does that sound right? No, those two things cannot be true at the same time unless the risk-free rate is 10%. Right? We're usually talking a risk-free rate way, way lower than that. And so these people, if someone tells you, I have a risk-free product that yields something above the risk-free rate, you know they are a liar. And then the old people question them, well, wait a minute, is this insured by the FDIC? Do you guys know about FDIC? Federal Deposit Insurance Corporation for bank deposits. And they'll say no, but we do have insurance through Lloyd's of London. And they'll show off this certificate showing that it's insured by Lloyd's of London. Total horseshit. Don't ever believe that. The minute someone tells you that they're going to give you an above risk-free rate for a risk-free asset, just walk away. And if you're feeling especially cheeky, call the FBI, right? And let them know. Questions? Okay, so we have basically those things that we talked about earlier, only now we've got long-term corporate bonds in the picture, and it falls exactly where we said it should, between long-term government bonds and large cap stocks. And if we look down, forget inflation, by the way, except for one thing. The return on U.S. Treasury bills, 3.6%. What's inflation? 3.1%. And so what does that mean? It means we have positive real return from investing in Treasury bills over the long haul. And so you can even grow your consumption a little bit and be totally, totally safe. Now, is that where we want to put all our retirement? No, especially not at your age. Okay, and then, so that's our risk-free asset. Then we move up to the, let's go, to the intermediate term government bonds. Same borrower, what's the difference? Yeah, time. These are, let's say these are 10, 20 years. And so they've got more price risk, but they've got exactly the same default risk. Can anyone tell me what the risk premium is for intermediate term government bonds? Say again? 1.9. How did you get that? 5.5 minus 3.6. 1.9% risk premium for those. What about the long-term government bonds? They're returning 6.1. What is the risk premium on those? Jace, I'll give you a chance to redeem yourself. No. Now we're up to the long-term government bonds. You need to get your eyes checked, bro, or come sit on the front row. Haircut, eyes check. Let's see. What is 6.1 minus 3.6? 2.5.
Where are we looking?
So we're taking the expected return on the thing minus our stand-in for the risk-free rate. What's our stand-in for the risk-free rate?
I'm not confident now. I don't think I've bought one.
Yarrow.
Yes.
Yes? No. Yeah, it's not a yes or no answer. Go ahead.
Risk premium is the meaning more risk, like appraisal.
Okay. I'm looking for a number, Yarrow. We've got
Number.
6.1% minus, yeah, 2.5. All he did was subtract 3.6%. Okay, now, something weird, and I'll get to the weirdness later. So, long-term corporate bonds, obviously you guys aren't necessarily catching on to this, so let's try this again. What is the risk premium for long-term corporate bonds? $2.8, very good. How did you get that? 6.4 minus 3.6. Okay, now I'm going to do one that's easy math to do in one's head. It's the large company stocks. Can someone, in fact, I'm going to call out, because I think you almost got the last one. I could see it on the tip of your tongue. What is the risk premium for large company stocks? 11, you're right, it's 11.8 minus 3.6. Can you tell me what that number is?
8.2.
Whoa, she's on fire. All right. And one more thing. What is the risk premium for small company stocks? 12.9, very good. That's just 16.5 minus 3.6. Okay, so as these things get riskier, we know risk and return have to go together. Now, there is a mathematical measure of risk that we will be diving into. It's called standard deviation. How many of you remember standard deviation from your QBA course? Like 3 of you. Okay, so standard deviation. You remember I talked about the roughness of those lines? Standard deviation is a mathematical expression of the roughness of the line. Okay, so if we start out down here with U.S. Treasury bills, the standard deviation of those things are 3.1. Now, going up from there, by the way, if they were truly risk-free, what would the standard deviation be?
Lower.
Yeah, it would be lower, probably close to 0, right? Okay, but we're going to see that they're, well, never mind. We'll get to that in chapter 11. Okay, so low standard deviation, and as we go up, something interesting happens. As we get riskier, that standard deviation goes up, and it goes up kind of along with the expected return, except for one thing up here. Check out long-term corporate bonds. They've got a higher return than long-term government bonds. That's consistent with them being riskier, right? But take a look at the standard deviation. Standard deviation is actually lower for long-term corporate bonds. We call this an anomaly. Anomaly. It just doesn't fit with the theory. It just doesn't fit. It doesn't fit with what we observe. Now, the question is this. You remember when we look at statistics, we say, well, we're 95% confident or we're 99% confident. Is it possible that this thing's off just because it's one of those weird statistical? Yeah, it's possible. Would I bet on this being true going forward? Probably not. But I'm going to stick with the theory over this. Okay, now I want you to look at the pictures over here on the left-hand side. Forget, once again, inflation. Look at the U.S. Treasury bills. And keep in mind that standard deviation is a measure of dispersion. If we're looking at the line this way, it looks like this. But if we're looking at a distribution, dispersion, it looks more like this. Okay, so with something with a very, very low standard deviation, it's going to be a very tall, skinny kind of distribution. It's going to look like a Christmas tree. It's going to be very tall and skinny. But as we get to more and more risky stuff, that thing spreads out. And by the time we get up to small company stocks, the standard deviation is so big that this thing looks like a fried egg. This is a fried egg from the side. I know I'm a terrible artist. Okay. That's what this thing looks like. It's all spread out. So when you see a distribution that's all spread out like that, you know it's got high standard deviation, and if it's an investment, it's risky. But when you see them like this, it's low standard deviation, it's very safe. What's the other thing we can say though? If I see a distribution like this compared to one like this, which one's got to have the higher central tendency? By the way, central tendency, expected value, mean. This one's got to have a higher expected return because it is riskier. So you could start looking at these things and you can actually see risk. Questions?
Is it a coincidence that the standard deviation for every dose is the same as the return on inflation? Or is that, are they tied together?
That's a good question. Actually, in theory, you're right. Because if the market were trying to, if people were demanding a small amount of positive return to hold the risk-free asset, then it's always going to be a little bit above inflation. And so as inflation goes up and down, so should the US Treasury bill. Now the fun thing here is it looks like inflation is actually more volatile than US Treasury bills. There's another word for you, volatile. We talk about volatility. So standard deviation is a measure of volatility. You're absolutely right. I hadn't thought of that. In fact, that might be something that I could do to write a paper that goes in one of those journals that no one ever reads. Would you like to be a co-author? Okay, very good. Okay. Other questions? Okay. So, we've got these, we've talked about the roughness, we've talked about, this sort of thing, but we need a mathematical measure, and I've kind of already let the cat out of the bag that we're going to use standard deviation, but we actually have two different measures we could talk about for dispersion. One of them is standard deviation, and the other one is variance. Do you guys remember variance? What is, Ms. Bartosh, what is the relationship between standard deviation and variance? Very good. Standard deviation is the square root of variance. And so if one of these things, they're basically measuring the same thing. So you think we might be willing to use them interchangeably, but we aren't, for two reasons. Number one, standard deviation is in units we can understand. So standard deviation is in the same units as the mean. And so if the return that we've got is in percentage, then your standard deviation is in percentage. And our little human minds can wrap around that quite easily. What if I told you to interpret a percentage squared number? Because the variance would be in percentage squared. You guys know how to interpret that? No! I've got a PhD and I don't know how to interpret that, right? Standard deviation, that's the way to go because it's a simpler unit for us to comprehend. And the second thing is, it allows us to describe the distribution of stock returns. If you remember last time, I told you that we assume that stocks are normally distributed. We know it's not quite true, but we assume they're normally distributed. And in order to totally construct a normal distribution, I only have to know two numbers. Those two numbers are the mean or central tendency or the middle tent pole, right? And then the standard deviation. And if I know those two things, I can totally generate that entire normal distribution, and then I can tell you all sorts of stuff about the probabilities of different returns happening. Okay, so simple your unit to interpret, and it feeds into the normal distribution. Those are the two reasons. Now, here we go. This is where people start to lose their lunch. Go ahead and get your calculator out. Go ahead and get your calculator out. And we're going to talk about how to calculate sample standard deviation. By the way, sample standard deviation versus population standard deviation. We only have a sample of the stock prices. So every day this stock is a random number generator and it's throwing out a return. Do we observe the entire population? No. So we only have a sample to look at. So what we're going to calculate is a sample standard deviation. If I know every possible outcome, then I can calculate the population standard deviation. But that's not what we're doing here. Chapter 10 is purely about sample statistics. Okay, so here we have a stock. And over 4 years, that stock has had the following returns: 13.7%, 35.8%, 45.14%, and negative 8.88%. The first thing we're going to do is to convert those numbers into decimals. First thing we're going to do is convert those numbers into decimals. I'm going to ask another mathematical genius, how do I convert percentages into decimals? Just move the decimal place. How many places? 2. Or I could also say divide by 100. Either way, whatever trips your trigger. Okay, so here we have our decimals: 0.137, 0.358, 0.4514, and negative 0.0888. Now you remember I've been going on and on about the mean or the central tendency and all that. How do you think we would come up with a mean for this set of returns? Yeah, it's just the average. And in fact, this is the same thing. If you ask your grandma to calculate an average, she'd be able to do this, right? You add them up and you divide by the number of things that you added up. And so what we're going to do is we're going to add these numbers up, and that's going to give us 0.8576. And then what number do we divide by? 4, because there are 4 observations. And when we do, we can see that the mean is 21.44%. Have I blown anybody's mind yet? Good. I'm glad you're still with me. Okay, now let's see what our next step is. So here's what we're really looking for. Notice it's called deviation. How far away is the current observation from that central tendency? And so the first thing we're going to calculate for each of these is the deviation. How do I do that? Well, I take the return from year 1 and subtract the expected return, or mean. What did we say the expected return was? 0.2144. And so if I take 0.137, in fact, let's get our calculators out and we'll walk through this together. If I take 0.137, subtract 0.2144, I get negative 0.0774. Now we're going to do that for each one of these, but I'm going to show you a way to make this easier. Most students, what do they want to do? They want to work this one column at a time. But what I'm going to tell you is we should work it one row at a time, and you'll see why. By the way, if we're doing this one column at a time, at this point you have a choice. You either store this in the calculator's memory or you write it down, right? Those are the two things. What if I could just leave it in there though, because the very next step, if you go one more over, we're going to square that deviation. We're going to square the deviation. Now, here's the big question. Why are we squaring the deviation? Well, if we just went through and added all those deviations together right now, I guarantee you they would sum to 0. They would sum to 0. And so the average deviation is 0. But we really don't care whether we're on this side of it or on this side of it. What we're trying to figure out is how far away from the middle we are. There are 2 ways for me to turn a negative number into a positive, just to measure that distance. One of them is called absolute value. You guys know about the bars, right? The other one is to square it. So if I square a negative deviation, and I've got some up here, if I square a negative deviation, I get a positive number. And then at the end, we're going to do a square root and we'll get back to where we were as far as our units go. Mr. Letterman, question? Okay, excellent. Okay, now I'm going to now show you the secret to doing this quickly. What we're going to do is we're going to do this next row right here. I'm going to go ahead and say, you see the X square button? And that gives me this number right here. So that's my squared deviation. Since that's the last thing on the row, I'm going to store that in location 1. Okay, then I'm going to clear it out. The next one, we're going to take 0.358, and what are we going to subtract? 0.2144 equals. This time I get 0.1436. What's my next step? Square it. And then what do? Store 2. Very good. Now I've got 0.4514 minus what? 0.2144 equal, what's my next step? Square it. And then what do? Store 3. Very good. Store 3. And then finally, this is the trickiest one, because you can't just start with, if I just hit negative to start with, that's not going to happen, right? So I've got to type in 0.0888. And sometimes students get so excited they totally forget to hit the negative key. By the way, what does a negative return mean? It means the value of the thing dropped over the year, right? The stock went down. Okay, now, what do I subtract? Yeah, subtract 0.2144. And because this was negative to begin with, this thing ends up even lower than minus the average. How do I get to this number right here? Square it. And what do I do with that number? Store 4. Okay, now the next step is for us to figure out something called the SSD. The SSD is the sum of squared deviations. The SSD is the sum of squared deviations. Now, I have 4 squared deviations. How do you think I'm going to get to the sum of the squared deviations? Add them all together. How am I going to do that with the calculator? Recall 1 plus recall 2 plus recall 3 plus recall 4 equals. That looks right. Now, the next question, and the next thing we can do is find the variance. That's just one step away from standard deviation. Now, here's the fun thing. How do I calculate the variance? Well, you might be saying, well, wait a minute, why don't I just take the sum of squared deviation and divide by the number of things? We can't do that because this is sample standard deviation. Do you remember that we use these numbers to calculate our estimate of the mean? Yeah, and statisticians tell us we have already consumed part of the information from our data set. And so they say we have lost a degree of freedom. We've lost a degree of freedom. And so instead of dividing by the 4 degrees that we would have originally, we are now doing 3. Now, if you don't understand the thoughts about degrees of freedom, please feel free to reach out to your QBA instructor, right? They'll be happy to talk all day about degrees of freedom. This isn't really my bag. Okay, I'm not a statistician. Okay, so how do we get the variance here? By the way, n, what does n represent? It's the sample size, right? And here, how many are we talking about? 4. So what should we be dividing by? 3. So I'm going to say divide by 3 equals, and I get 0.05823699. How do I get from here to standard deviation? Say again? Square root, very good. I'm going to hit this square root button. That's where it's at right there. Boom. I'm getting 0.2413, which is actually 24.13%. How did we get 24.13% from that number? What did we do? Yeah, multiply by 100%, right? Because multiplying by 1 doesn't change anything, and 100% is 1. Okay, so now we've got a standard deviation of 24.13%, and we also have a mean of 21.44%. That means we could actually right now generate the normal distribution for this set of outcomes. Now, did that seem like a total pain in the butt? Would you like to know an easier way? Yes. Absolutely. Okay, so here we go. Get your calculator up, and we're going to say second and the number 7. What does the number 7 say above it? Data. So this is where we're going to enter our data. Now, this thing is just like the cash flow key. It remembers everything you've ever done. And so the first thing I'm going to do is hit second and then clear to clear out all of the previous data. And here's the reason I do that. This time I'm doing 4. What if last time I did 5? I'm going to have a 5th one hanging out there just waiting to trash my results, so I don't want to do that. Okay, so what should we put in for x01? Yeah, so we could do it either way. In this case, we can use either percentage, bless you, we could use either percentage or decimals. We already have the decimals here. Let's put those in. 0.137. Now the next thing, when I arrow down, it says something about y. We're only working with one stock here. It turns out your calculator can compare 2 stocks, and that'll give us some useful information for chapter 11, but not here. So we're not doing anything with that. So instead, I just arrow on down. What do you think I should put in for x02? Point what? 0.358. Very good. 0.358. Enter. Arrow down. What do I do now? Arrow down. What's x03? Yeah, 0.4514. Enter. Arrow down. What's y03? Yeah, we just need to arrow down again. Now, here's a tricky one. x04. 0.0888. What do I have to do? Negative. Very good. And I hit enter. By the way, if I don't hit enter, the calculator just totally does not accept it. And so what I'm going to do here is I'm going to arrow back up and make sure all my numbers are in there and in there correctly, because I'm just that paranoid. Okay, now that we have all of our data in, we can say, we can hit the second button and then hit number 8. What does number 8 say above it? Stat, which is short for statistics. And then, back when I used to have more Chinese students, there would always be someone named Lean, right? And they would think, wow, the calculator knows who I am. That's not true. It's short for linear, right? Is that meaningful to you? No, don't worry about it. So where do we go from here? Well, if you look up top, it says I have 3 options here. I've got set, up, down, or up and down. So I'm going to go down. And it says n is equal to 4. Does that sound right? Yeah, we've got 4 samples. We've got 4 returns, right? If you get a different number here than the number of returns you put in, what it means is that you failed to clear out your data sheet before you started. You need to go back and fix that. Okay, so far so good. Arrow down. X bar is equal to 0.2144. Does that number look familiar? Yeah, it's just the mean, right? It's just the mean. By the way, X bar, whenever we put a bar over something, that just means average, right? Okay. Arrow down. S sub x is equal to 0.2413 blah, blah, blah. What does that look like? Yeah, it's the same standard deviation that we calculated earlier, isn't it? Now, which was easier to do? The doing the subtracting and the squaring and the summing and no. Ms. Steele says no, right? Okay, so this is definitely the easier way to go. It's going to be faster. So if you're doing sample standard deviation stuff, I would recommend doing this for two reasons. Number one, it's faster, and number two, you are less likely to make mistakes. Very good. Questions?
What's the lean mean? Do you have to worry about lean?
No, don't worry about lean. I think she's back in China. Okay, so now I will show you something here, and I will preface it with a story. When I was a little kid, I'm watching my mother cook. She's cooking on the top of the stove, and she said, and I'm a curious boy, right? And she sees me eyeballing the burner on the stove. It's a nice cherry red, right? She says, what does she say? Don't touch the burner. And then she turned around to get a spoon, and what do? I learned the hard way. I don't want you to learn the hard way. Although I was warned, you're being warned, some of you will go ahead and touch the burner. But here we go. If we arrow down one more, we get sigma sub x. That is population standard deviation. But we don't have the whole population here. We only have a sample. So do not use this for anything in this class. Let me say that again. Never use this for anything in this class. Don't. Some of you will touch the stove just like I did, but you'll get burned and you'll get over it. I've got the feeling back in my hands after 27 years. It came back very helpful. Okay, questions?
The essence against standard deviation, right?
Yeah, okay, so a sample standard deviation. Now, let's ask this question. What if on the exam I've asked you for the variance? You say, crap, the calculator does not compute variance for me. What do? Just square it, right? And if we square this thing, boop, come on, there we go. Nope, oh, it did it, sorry. Let's go, okay, so how do I get it back? Arrow up, arrow down. If I square this thing, I get exactly this number I got before. And why isn't it exactly? Because I've got 9 decimals and they only used 8 on the slide. So it's still easier to go this way and then square it than to go the other way.
Can you use square roots to get back to the original number?
Yeah, there's 2 ways I can get back to the original number. I can either square root it or I could do up, down. And when I do, it does this thing right here. It shows me this asterisk, which tells me that it's a number that it came up with, not me. And so, in fact, all of these, even the n, it says, wait a minute, I counted those, there's 4. And then it says, hey, I calculated this mean. That's what the star means. It's a number the calculator came up with on its own.
Okay, so it's the original number that the calculator came up with.
Yeah, and so if I get down here and I square this thing, notice what happened to the star. It went away. The calculator says, hey pal, I'm not responsible for this number. The other clue is that the equal sign went away. This is 1980s technology at its very best. Questions? Okay. Students usually prefer the easy way. Now, we said if we have the mean and the standard deviation, we can compute something called the normal distribution. Now, the normal distribution is shaped like a, what do we usually call it? What kind of curve? Yeah, it's a bell, shaped like a bell. Now, first thing you need to know is that every possible outcome is contained underneath the normal distribution. And so if I said, what is the probability of all of the events under the curve of the normal distribution? The answer is 100%. 100%. And that center is going to either be your mean, which we also call average, or something else we're going to call expected return. Which, by the way, usually expected return we are calculating using historical data. And so it's just going to be the mean. When we get into chapter 11, you're going to see that it's not always the case. But for now, enjoy the simplicity of your life as it is. Okay, now, how do we generate the rest of this curve? We've got the tent pole, now we've got our standard deviations. And we are going to mark off plus 1 standard deviation away from the mean, plus 2 standard deviations away from the mean, and plus 3 standard deviations away from the mean. Now I want you to notice that they're using sigma here for standard deviation. Remember, sigma is used for population statistics, but what we're going to be putting in here is our sample standard deviation, and we're going to be coming up with a sample distribution. Okay, now we do the same thing coming this way, minus 1 standard deviation, minus 2 standard deviations, minus 3 standard deviations. Now, you say, wait a minute, that's all I've ever heard of, plus and minus 3 standard deviations. Is there more to the world than that? Yes. In theory, the normal distribution goes on forever in that direction, and it also goes on forever in that direction. And for stocks, it's possible to have an infinite return. Theoretically. Is it possible to have a negative infinite return? No. What's the worst return we can ever get? Well, yeah, we lose everything, right? So minus 100%. Stock goes to 0. Limited liability keeps stock prices from going negative. So that means we are truncated. Do you know the word truncated? Just chopped off. They're at minus 100%.
But if you were investing and you were taking a short position, you would.
Oh yeah. If you're such a I'm sorry. If you were so inclined, but we're not talking about short position here. We're talking about a long position. Yeah, he's absolutely right. If you do a short, the other way is true, right? You could gain up to 100%, but you can lose infinitely. Which would you rather do? Have the potential of losing 100% or gaining infinity, or have the potential of gaining 100% or losing infinity? There's a reason I don't short stocks, right? So, how many of you think there are stocks that are currently overpriced? Yeah. In fact, we could probably sit here and name some of them. And I've been in a position to actually point them out before. And my students say, why don't you take a short position? A short position is when you borrow the stock from someone else, you sell it, and you hope the price goes down so you can buy it back and replace it at a lower cost. In the meantime, you have to pay interest and you have to pay the dividends to the person you borrowed the shares from. And as my dissertation advisor once said, the market can stay irrational longer than you can stay liquid. So you're paying out these dividends, you're paying the interest, and of course there are fees involved too. And what happens if the market keeps this stupid high valuation for a long period of time? Yeah, you're going to go bankrupt. And probably the day after you go bankrupt, that stock will take a huge dump. At least that's been my luck, right? Okay. Does that help you think more clearly about shorting stocks? Yeah. Now, the best way in the world to do shorts is to do a lot of investigation about a company. Make sure that you know everything about them, and make sure that you have your facts so well documented that they can't successfully sue you. And then you take a huge short position and you release your information to the world. So, for example, Muddy Waters is a very famous firm that does exactly this same thing. And they have been right so many times. One of the things that they did was call out a Chinese forestry company that said they owned more acres of woods than existed in the entire People's Republic of China. I mean, if you just do the math, you can figure out that's horse crap, right? Because they were a total Chinese company. And so they put this information out there, the stock crashes, they make a profit. Someone else, Hindenburg, put the dime out on Carvana. Carvana, you guys know about Carvana? Yeah, Carvana got really, really low, but it didn't quite die. And now it's taken off. If those people are still in a short position, they are in a world of hurt. Oh, Carvana, it's an online used car dealership. And you can buy and sell your car just from the comfort of your own couch on your phone. What do I think it is? I think it's a front. I think it's a scam for it's a father-son duo. I forget their name. But they've got a private entity that they're doing business with. And the private entity, for instance, is buying up all the bad debt from Carvana. And then what are they going to do with that private entity? Well, it'll go bankrupt, but Carvana will be fine, right? So in the meantime, how are they making money on this whole thing? Well, they had a bunch of stock in Carvana, and they're selling billions of dollars worth of Carvana stock every year. By the way, if you see the CEO of the firm and their dad selling the stock, what should that tell you? Get out, right? Does that make sense? Yeah, when you see the captain of the ship running for the lifeboat, yeah, get out. Okay, so normal distribution. It not only measures stock returns. Let's start and talk about one of the most famous ones, and that is IQ. What does IQ stand for? Intelligence quotient. So it turns out back in the 19th century, there was this French guy, and he says, you know, some of these people aren't quite as bright as the others. I wonder if we could put a number on that. And so he came up with some cognitive tests. And what he did was he figured out that the scores on this cognitive test, were normally distributed. Now, his test, who knows what the average score was on his test, but what he did was scale it to be 100. And so if your IQ today is 100, that means you are exactly as intelligent as one of the French school children from the 19th century that this guy did his work on, right? Okay, now the other thing that he noticed was that the standard deviation of his new measure was 15. So the standard deviation of intelligence is 15. And in fact, if you look at some of the early names that we put on certain levels of IQ, they all come from the number of standard deviations above or below the mean. So let's start down on at -2 standard deviations. 2 times 15 is 30. 100 minus 30 is 70. Now, when I was a child and they were measuring my IQ, the word for that was mentally retarded. Now, that's a bad word now, right? But we can't judge the past based on today's standards. We have to look back then. Back then, that's just a scientific term. And I guarantee you that whatever word we come up with today, that will become a bad word in the future, right? Because no one wants to be called dumb. Does that make sense? I don't want to be. I mean, I get called that, but I don't want to be. So on with the story. I don't remember that there's any name for 85. If you're 100, you're average. If you're 2 standard deviations above, that means 130 or above, you're gifted. And if you were so lucky as to be 3 standard deviations above the mean, you are a genius, right? So that's where these come from, is it's broken up by standard deviations. Now, the question is this: what can we use this normal distribution to tell us about the proportions of the population that are in these different groups? For example, if I ask you how many people have an IQ between 85 and 115. So the first thing I'm going to do, I'm going to say, well, let's see, 115, and I'm looking for the number of standard deviations above or below the mean. So I'm going to subtract the mean, and then I'm going to divide by the standard deviation. What's the standard deviation of intelligence? 15. In fact, let me go ahead and write this out. T is equal to x minus x bar divided by s sub x. T is just the number of standard deviations you are away from the mean. So this one is 15 over 15. What's 15 over 15? Yeah, so we're at +1. Now, what if I say 85 minus 100 divided by 15? That's going to be equal to -1. And so basically where we're looking at on the normal distribution is between -1 and +1. Now, here's the really magical thing. Every normal distribution in the world between -1 standard deviation and +1 standard deviation is 68.26% of all observations. So there is a 68.26% chance that anybody, any given person, has an IQ between 85 and 115. Does that make sense? Okay. Now, what if I said, what's the proportion of people who have an IQ between 70 and 130? Well, if I do 70 minus 100 divide by 15, I get -2. And if I do 130 minus 100 divided by 15, I get +2. Well, it turns out that in every normal distribution ever, between -2 standard deviations and +2 standard deviations is 95.44% of all observations. There's a 95.44% chance that your IQ is between 70 and 130. Okay, now let's take it even further. What if I said, how many people have an IQ between 55 and 145? Well, 55 minus 100 is -45. Divide by 15 is how much? -3. And 145 minus 100 is 45. Divide by 15 is +3. Well, it turns out that in every normal distribution ever, between -3 standard deviations and +3 standard deviations, we have 99.74% of all observations. There's a 99.74% chance that your IQ is between 55 and 145. Now, let's ask this question. What is the probability that your IQ is over 145? How would we calculate that? Yeah. So she's telling us how, you're telling us the number. I like both. Okay, so here's what we're going to do. Here's what we need to keep in mind. That in between these two things is 99.74%. And we said that under the whole thing is how much? 100%. And so we're going to take 100 minus 99.74%. And that's going to give us 0.26%. However, we need to keep in mind that that's broken up over both of these tails, right? So the thing is symmetric. How much does that mean is in each tail? Symmetric means it looks the same on both sides. So if we got 0.26% in two tails, how much is in one tail? 0.13%. So here's the experiment that I want you to do. Go ahead and get your calculator. And we're going to, let's say, congratulations. Today you found out you have an IQ of 145. You are a genius, right? You are woo, way up there. So let's see what that really means for you. Let's take 8 followed by 9 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3. Why do I have 8 billion in there? How many people live on this planet, so far as we know? 8 billion, around 8 billion. Okay, now, how many of those people are smarter than you? We multiply by 0.0013, because that's 0.13%. It turns out there are 10.4 million people on the planet who are smarter than you. You were feeling pretty good a minute ago, weren't you? Now you realize there are 10 million people on the planet who are smarter than you. But I have good news. A lot of those people live in places where they don't have the internet, they don't have electricity, and you won't ever have to compete with them. So literally you're probably only competing against another 5 or 6 million people, right? Does that comfort you any? No. Okay. Good news is there's plenty of work for all of us, right? We hope. Okay, so that's normal distribution. Now, what about with stocks? What we have here is large company stocks, and I could tell that because the mean is 11.8, which is exactly what it was on that slide a couple ago for large company stocks. We also, we have it marked off here that plus 1 standard deviation is 32.3, plus 2 is 52.8. Can anybody tell me what the standard deviation, without flipping back, can you tell me just from looking at this picture, what is the standard deviation of returns for large company stocks? 20.5%. How'd you come up with that? Yeah, 32.3 minus 11.8, because 32.3 is plus 1 standard deviation, and 0 standard deviation is 11.8. We can check his work. What is 11.8 minus 20.5? It's negative 8.7%. And so now we know that the standard deviation is going to be 20.5. So I'm going to go ahead and write that up here. Okay, so first question. What percentage of returns are between minus 8.7% and 32.3%? Yeah, 68.26%. Oh, by the way, most of the time we use these approximations. We use 68, 95, and 99. So this is going to be our plus or minus 1, plus or minus 2, plus or minus 3. For purposes of homework and exams, entirely likely that these will be the numbers that we use. The multiple choices will never be so far off that regardless of which one you use, you'll be okay. Have this on your note sheet. Let me repeat that. Have this on your note sheet. And here's why. I was teaching China MBA, and I had one of my students in there was from Mongolia. Do we have anybody from Mongolia here? Nobody's here from Mongolia. Okay. Because now I can tell you the story just totally honestly, because there's no one from Mongolia here. Okay, so this lady, she's a lovely woman, and in fact, she and I are still friends on WeChat all these years later. But during the exam, she gets a question where I'm asking about the probability of stock returns. And I had given her a sample of stock returns from which she could calculate the mean and the standard deviation, and she had done that. But she missed out on how do I jump from that to the probabilities. And the answer is the normal distribution. And she calls me up to her desk and she said, "You did not give me enough information to calculate this probability." And I tap on her note sheet and I say, "Yes, I did." She gives me a dirty look and she says, "No, you didn't." And I say, "Yes, I did." At which point she reaches out to grab my lapels of my coat. I was quicker back then. She would have pulled me over the table today. But why do I tell you that story? When you are seeing questions about probabilities on the exam, I always want you to think about the normal distribution. That's what we're talking about. Okay, now, so we know how to play around with this thing, and it would be easy for us to ask the simple questions. But let's start asking some of the harder ones. What percentage of returns will be above 32.3%? First step, when I get that question, I say 32.3 minus the mean. What's the mean here? 11.8. What is 32.3 minus 11.8? 20.5 divided by standard deviation. 20.5 gives us plus 1. So now we know how far we are away from the mean. Now, how do we go from there to knowing what proportion of returns are higher than 32.3?
68 or 68.26?
Whatever trips your trigger, man. I'll tell you which one's easier to do in your head.
Definitely 68.
Yeah, but I'll let me guess. You can't do that one in your head either.
Well, I got it.
Okay, what is it?
It would be 32, but if
Woof.
it's over, it'd be 16.
Yeah, he's on fire. I am very pleased you could do that in your head. So 100 minus 68 is 32, but that is both tails, right? And so if we're just looking above that, it would be 16%. So far, so good. Okay, what if I ask you, what is the probability that the firm or that the stock will lose more than 29.2% of its value? What is the probability the stock will lose more than 29.2% of its value? Well, the first thing you need to recognize that when I say the word lose, is that plus or minus? Minus. So it'd be minus 29.2 minus 11.8. When I put those together, I think it's minus 41. Does that sound right? Minus 41 divided by 20.5 is minus 2. And if I'm asking what probability we're going to lose more than that, we're talking about this tail over here. Okay, so let's use the approximations. What's my first step? 100 minus 95, which gives us 5. What does 5 divide by 2? 2.5. So there's a 2.5% chance that the stock will return less than, or will lose more than 29.2%. Or I could also say return less than negative 29.2%. Means the same thing. Once again, English comes into play. Because if I ask you about losing, a lot of times students will look at that, they won't see that as a minus, and then they'll divide by the standard deviation, and they'll say, wait a minute, 29.2 divided by 20.5, that doesn't come out evenly. All of his other examples came out evenly, right? By the way, on the exam, all my stuff is designed to come out evenly. All my stuff's designed to come out evenly, because if it's not, I have to give you a table. I'm not going to do that. So it's designed to come out evenly. If you get a number, if you're doing this with real world data and you come up with some other, you can always use the tables, right, from your old QBA books, your stat book. Okay, so now let's get really tricky. What is the probability that the stock will not lose more than 49.7%? What is the probability that the stock will not lose more than 29.7%? 49.7%. So here we are, we're over at negative 3 standard deviations. If I put negative 49.7 minus 11.8 divided by 20.5, I would get minus 3. I'm over here at minus 3 standard deviations, and I'm asking what's the probability that it won't lose more than 49.7%. So basically, I'm talking about everything but that tail, right? Everything but that tail. So how do I go about that? I would figure out how much is in the tail and subtract it from 100. Okay, between, and using the approximations, how much is between plus and minus 3%? Yeah, 99%. Right? 99% between, and I'm sorry, I said percentage. I mean, so between minus 3 standard deviations and plus 3 standard deviations is 99%, right? So how much does that leave in each tail? 0.5%. And so there's 2 ways we can go about it at this point. We could say, okay, we're going to take that 99% and we're going to add that 0.5% on the other tail, and that's going to give us 99.5. Or we could say we're going to take 100% and we're going to subtract this little tail over here, which is going to leave us 0.5%. I guarantee you, you have not comprehended this material from listening to me the first time. So here's what I would advise you to do. I want you to go back and watch this video. Now, I'm going to post this after class. Watch this video. And then I want you to go through all the practice problems. And as you run into questions with this, which I know you will, even if you're confident right now, I know you will, I want you to copy and paste that stuff into an email and send it to me. Why is it important to copy and paste? Because you write down wrong numbers when you're typing stuff in, and then we both get frustrated, right? Copy and paste. And that way I'm seeing what you're seeing. Does that make sense? Okay. So that's the normal distribution and stocks. Now let's talk about something called arithmetic versus geometric average. The arithmetic average, that's the one that you've been taught your entire life. And it's the one that we use most in statistics. For example, when we're figuring standard deviation for a sample, we'll be subtracting the arithmetic mean. And it's real easy. You just add all the returns up and divide by the number of returns. But it doesn't necessarily tell us everything we need to know. And so another thing that we use is called the geometric return. By the way, the top one could be either percentages or decimals. As long as you put all percentages in, you'll get a percentage out. If you put all decimals in, you'll get a decimal out. If you mix them up, you will not get it right. The geometric average, however, when we put R in here, it always must be a decimal. It always must be a decimal. It always must be a decimal. Okay, and what we're going to do is we're going to add each one of the returns to 1. Then we're going to multiply each one of those 1 plus R terms together. If we have 17 returns, we're going to have 17 of these 1 plus R things that we're going to multiply together. And then we're going to take that product to the 1 over n power. N is the number of returns that we use to calculate this. If I put 17 of them in there, it would be to the 1/17th power. You're saying, how in the world do I do to the 1/17th power? I will show you. I will show you. Okay, then we have 2 more steps. We subtract 1. Remember how we added 1 to all those returns to begin with? What's 1 times 1 times 1 times 1? 1. So at the end we subtract 1. Now that may not be mathematically accurate, but it helps you to remember. You've got to subtract 1, right? Okay. Now, then I multiply by 100% to get it into percentages. So let's do an example here to show you the difference between these things. So we have a portfolio that's worth 100 at time 0. It's worth 50 at time 1, and it's worth 75 at time 2. We cannot find a return for time 0 because we always need the prior value, and we don't have it. So there's no return there. The return here, 50 minus 100 is minus 50. Divide by 100 is minus 0.50. Are you with me so far? Okay, here we have 75. And by the way, when we do returns, we're always looking at the prior value. So it's 75 minus 50. How much is that? 25. And what is 25 divided by 50? 0.5. Okay, so I have 2 returns here. Can anybody tell me what the arithmetic average is? It's not a trick. 0, right? Because if I take plus 0.5 and negative 0.5 and I add them together, divide by 2, it's 0. Now, you're saying, whoop, that's great. I haven't lost anything. Is that true? You're actually down 25%, aren't you, over 2 years? The problem is arithmetic does not take compounding into account. Arithmetic does not take compounding into account. Geometric does. So let's do our deal here. So in our calculator, the first one is going to be 1 plus r. What is 1 minus 0.5? Yeah, it's just 0.5, right? 1 minus 0.5 is 0.5. Then I'm going to multiply by the second one is going to be 1 plus 0.5. So it's going to be 1.5. That gives us 0.75. Now I'm going to raise that to the 1 over n power. What is n? 2, right? And so here's what I'm going to do. I could just do square root. For the mathematically literate among you, you know that to the 1/2 power is just square root. But I'm going to make it to where you can do this for all of them. I want you to hit the button right above 9. What does it say? Y to the x. And then I want you to hit open parentheses. 1 divide by n, which is 2 in this case, close parentheses, equal. Okay, so there we are. We've got 0.866. What's the next step the formula tells us we must do? Yeah, minus 1. And that gives us minus 13, or 0.1339. What's my last step? Yeah, multiply by 100. So there we go. I'm getting negative 13.397%. That makes more sense. If you think that we're losing 25% over 2 years, I would expect this annual loss to be somewhere around 12.5%, right? Just spitballing. And so that makes a whole lot more sense. So I'm going to store this in location 1 just to show you something here. If I clear out my time value of money and I put in future value of 75 and I put in present value of 100, negative, and n of 2, if I compute I per y, do you recognize the number? Yeah. It's the same number. In the absence of dividends, you can do this. But your homework problem for this includes dividends. And I want to give you a hint on the homework. Are you ready for a hint? Those dividend numbers, they'll be like 0.25, 0.75. They'll be things like that. They didn't put a 0 in front of it, and they made the decimal place so tiny that you may not be able to see it. So look very closely, because what you think is 75 is likely 0.75 for the dividend. Now, another way to look at that is if the stock's trading for $10, would it really be paying a $75 dividend? No, not going to happen. So look very closely. I have made a very detailed video on how to work the problem that is on your homework. Let me say that one more time. I have worked a very detailed video on how to work this problem. It's in the example folders, for, video examples under chapter 10. And so you can actually take a look at that and you'll be able to solve that for yourself. Now, I think we have one slide left. It's a little complex, but the good news is, so I'll cover this slide next time. But now you are armed with everything that you need to do all the practice questions and all the homework. So I will not be delaying the homework. I know you guys were sweating it and worried that I would delay it, but thankfully I don't have to. Any questions?
I have a question, sorry.
Go ahead.
When we calculate standard deviation in the calculator, what do A and B represent at the x on the line?
Say that one more time.
So like, you know, like when we calculated standard deviation, there was A and B at the x. Like when we click the arrow down, there was like A and B.
Oh, I didn't go that far down. I don't know. Never been that far down. I don't go below S sub x. Why? It's like touching a hot stove, right?
Okay. And then one more question. Does this probability, that's what you're going to be like on the test or like homework?
I will make it clear what I want you to calculate. If I want geometric average, I'll tell you that. Oh, here's one more fun thing. Geometric average, if returns are positive, geometric average is always lower than arithmetic average. Geometric average, when returns are positive, is always lower than arithmetic average, and I will prove that to you next time. Okay, see you guys next time.